Assalamu alaikum. Good morning, everyone. Thanks for joining us today. I'm Nisar Kar from Market Studies Department of SIDF. We welcome you all for our very own special November event. Before we start, we will present a safety moment, and our colleague, Mr. Turki Al-Mulhim from the Facilities Management Department, will give us.
السلام عليكم، صباح الخير جميعا. بحكم انه فيه زوار يتحدثون اللغة الإنجليزية بنعطي السيفتي مومنت باللغة الإنجليزية. Good morning. I would like to share with you the safety moment for today. Here in this IDF, we value safety very importantly or very highly. Therefore, I'd like to share some steps or procedures that can be helpful in case of an emergency evacuation, God forbid. We are currently located in CAFT area number 3, building 3.04. We are in the second floor on the west side of the building. You can see blue arrows and you can see green arrows. The blue arrow is the nearest exit to us. It will lead us to the assembly point. You can find the map, the overall map of the building on the bottom. The assembly point on the top left, over here, indicated by the blue arrows, is the mosque assembly point. The green arrows will lead us to the second assembly point, which is the Wadi area assembly point. It's not necessary to, or necessarily you need to go to a certain assembly point. It depends on the situation and the number of people on each assembly point. We don't have a fire drill scheduled for today, but if there is a fire alarm activation, wait for the fire warden's further instructions to head to the exits. The emergency contact number is 1999. This is a specific number to SIDF. You can call this number through your personal mobile phone by calling SIDF main number, then the last 4 digits, you'll change it to 1999. Thank you all, and may Allah keep us safe and sound, inshallah. Shukran.
Thank you very much, Mr. Turki. I would like to extend a warm welcome to all those present here, joining us in person or joining us through social media online. And we are thrilled to have with us today as we gather for our exciting workshop on new trends in plastic packaging. So let's meet the speakers. Today, HotPack will be sharing knowledge about their efforts in producing the sustainable plastic packaging for various industries. And with us, we have Dr. Mike Sheatham, Global Business Director. However, Engineer Hashim Ali Hashim could not be with us due to his family emergency. Dr. Mike Sheatham is a renowned leader in sustainable packaging and serves as a head of sustainability at Hot Packaging Industries, which is one of the largest manufacturing in plastic packaging. Under his guidance, HotPack has become a major player in the plastic packaging globally and producing more than 4,000 items. Please join me in welcoming Dr. Mike Sheatham on the stage to share insights about the sustainable plastic packaging. The floor is yours.
Thank you very much. Good morning. What a fabulous place to work. Amazing. I was here 2 weeks ago. We are planning to build our largest global facility in the city of Riyadh, 1.2 million square feet. And I know that we have an application in with SIDF at the moment to help partner us with this project. What I'm going to do is I'm going to show you some of the ideas. I never thought the packaging would be so exciting. I'm a medical doctor by training. I retired 20 years ago to Dubai, never to work again. And now we're standing here in Saudi looking for this country to be the best, to be the flagship in the world in terms of food and food packaging. So let me give you an insight into what we plan for this country. Short video first, and then I can sit down. I don't need to speak. How do we play?
The pursuit of excellence always leads to new beginnings. New beginnings to carve the future, such as the story of HotPack, the region's largest manufacturer of top quality, hygienic, sustainable packaging products. From humble beginnings, HotPack has not just grown in size but in strength over a span of 3 decades. From a team of 3 to over 4,000 has been an incredible journey. Hailing from 30+ different nationalities, embracing each other's culture, and working steadfastly as a team together to produce more than 4,000 variety of products, serving 25,000 international brands. HotPack has developed a massive portfolio of products as a pioneer in producing responsible packaging merchandise for various industries including food and beverage, retail, travel, entertainment, hospitality, healthcare, pharmaceutical, home and personal care businesses. Key infrastructure portfolio includes 20 manufacturing plants with 3 million square feet, manufacturing area 50 sales centers, and 30 branches across globe. We take pride in the international accreditation, including the BRCGS AA grade and FDA approved. There are testimony to our commitment to quality and being an ISO CEDEX, ESMA and CISO certified company. HotPack has received numerous awards, including the esteemed Dubai Quality Smart Industry Award in 2020, and we are recognized by Dubai Industries and Exports as verified exporter. Out-state-of-the-art manufacturing facilities with advanced equipments and IR 4.0 technologies along with skilled R&D department enable us to produce a wide variety of products meeting the needs of the market. HotPack's paper cup division produces over 3 million high-quality cups per day. In their folding carton division, they are equipped to produce all kinds of paperboard containers and boxes to serve food packaging. This facility of HotPack is equipped with most advanced ESCO platform with a web center. HotPack offers a range of hygiene products under the Soft and Cool brand, including gloves, masks, hand washes, cleaning liquids, sanitizers, facial tissues, napkins, kitchen tissues, and toilet rolls. Another feather in the cap is HotPack's labeling and stickers division. Sophisticated state-of-the-art machines produce different kinds of stickers and self-adhesive labels. HotPack has been working towards providing solutions for recyclability in their products. This has prompted them to invest in state-of-the-art water-based coating lines and similar technology. HotPack Advanced PET Plant has been leading their initiative to provide monomaterial to ensure complete recyclability in the PCR category. Their team has been relentlessly working towards collaborating with their customers, government bodies, and other stakeholders to push for sustainable packaging solutions. HotPack's largest state-of-the-art manufacturing facility is taking shape in the Kingdom of Saudi Arabia. Announced with a budget of 1 billion Saudi riyals, this massive 100,000 square meter multi-division complex will be the world's largest hub for sustainable food packaging. Its first phase is expected to be completed within 2 years. Continuous improvement is the key, and HotPack believes it is not just about creating packaging, but also creating opportunities and enabling people and processes. As the conglomerate continues to spread its wings far and wide, HotPack invites you to join in and be the wind beneath its wings, helping it soar higher. Together, let's carve the future.
So there we are. I don't need to say anything else. You have it all on the video. You saw the size of the project that we're planning for this country. We'll provide the packaging infrastructure for the pharmaceutical sector, industrial sector, food sector, and many other areas as well. Our machines are capable of producing every substrate: paper, plastic, aluminium, recyclables, plant-based, you name it, we have it ready for this country. You can see our footprint around the world. We have many nationalities, 4,000 team members. We're hoping to, I think it's 1,500 to 2,000 new team members in Saudi once we're fully operational. Certification's everything in the food sector. We want to be food safe, and the gold standard is the BRCGS. If you're looking at any inward company coming here into Saudi, you should make sure that they have that certificate. It's very hard to get. We got a grade A the first time, and at Hotpack, we love criticism. So we looked at the small print, we went back, and we got a double A, and then we've had random visits, and now I believe we're the only packaging company in the Middle East with a double A+. This is key. Unfortunately, in this region, having come from Europe, we throw everything away. It all goes into landfill. We've also seen the huge mounds of waste going into the ground. And for the last 10 years now, there's been a big move towards recycling, biodegradables, compostables, which we have in our range. We've moved our customer base to recycled materials now, biodegradables, 96%. The 4% is things like polystyrene, which we don't make. We trade it, but we're gradually offering alternatives to our customers. So I'd like soon that to be 100% on the slide, certainly when we come here. We supply everybody, every restaurant, every cafe, hotels, industrial packaging, all the giants, they buy our products, the hotel chains, supermarkets. And we have 50 retail centers. We've opened our first one in Riyadh. I said it would never work. Nobody's going to go to a shop to buy food packaging. That was 3 years ago. We now have 50, and they're a runaway success. First of all, it's a window for our products. Secondly, we can use it for a test bed. People buy it for home, for their barbecues, for their home. Offices go there, and they buy the supplies once a month. And surprisingly, many of the hotel chains, the restaurants, they go there. If they run out, they need something quickly. So expect to see a lot of these in Saudi. This is the problem. It's actually the 4 Ps: public, plastic, packaging, perception. Whenever anybody thinks of plastic, and obviously SABIC is one of the largest producers in the world of plastic, this is what people think. I always say, this is not a plastic problem, this is a human problem. The humans are throwing it away. As you'll see, we have invested in machines that can take that, if it's cleaned, if it's sorted, and we can make the same thing out of it again in a complete closed loop. So that is a human problem, and that's what we need to address in this country. We're sitting on the National Steering Committee of Saudi, and we're working with your government to bring the very best of thinking and evidence-based, not just copying what the other countries around the world to do. We want Saudi to study the science of what is the best for the environment. When future generations look back, we want them to admire Saudi for what you've done, not just copy everybody else. It started off initially for 50 years, packaging was just thrown away, and then slowly we started to introduce the 4 Rs, which was reduce, reuse, remanufacture, recycle. Since then it's grown up to 9. We're up to the 9. I believe there's a 10, and I think we're up to 13 at the moment. So we're doing our bit. Obviously, the key thing is to have circular economy. These are valuable materials. We don't want to throw them away. We can use them again. And so it's very important that we move towards a true circular economy. At our factories, all 20 of them, we're doing our part. We have 0 landfill. We view these materials as essential, and so we throw nothing away. We have machines that can recycle it, regrind it, reprocess it, and we use everything ourselves. That's post-industrial waste, PIR. It's clean, it's sorted, and we can use it all. The challenge is with post-consumer waste, PCR, because as you've seen, all the rubbish is a mess. There's been a big move towards biodegradable, compostable. I'm sure if I ask you to put your hand up, you'll all say that's fabulous, it's great for the environment. But and there's a big move. Nearly half of our products are paperboard, biodegradables. We make products from rice, from straw, from bagasse, and that is a fashion at the moment. But the evidence is showing that in many cases plastic is better. A paper cup takes 3 times the carbon footprint to make than a plastic cup. A plastic cup can be recycled back round into a plastic cup, again, in a closed loop. A paper cup gets downcycled. It gets downcycled into a cardboard box, a carton, and if it goes in the ground, it biodegrades into greenhouse gases. It produces carbon dioxide and methane. So don't think that biodegradable is always the best solution. It's not. The answer is that there has to be a sensible balance of everything, and it needs to be evidence-based. So these are some of the ideas that we are working on. This is polystyrene, which is one of the hardest. It can be recycled, but it's one of the harder ones. So we have pulp-based, craft-based, biocraft, bagasse. Whatever you want, we've got the replacements. So this is a very important slide here. Again, as I said, a paper cup here is 1.5 times more energy than a plastic cup. I've seen it as high as 5 times, depends on the study. And in many cases, we found that paper is far worse for the environment. So, and the interesting one is that when you talk about carbon footprint, often the food is 96% of the carbon footprint, the food production. The packaging, the cup, is only 4% of the climate impact. So the first attempt in the industry was PLA. PLA is 100% biodegradable, but unfortunately it's only industrially compostable. So that means that it has to be collected separately, you can't identify it, and it has to be taken to specialist recycling centres where it's heated for 3 days at 60 degrees. You can imagine the energy required to do that. So PLA was the first attempt, but perhaps not the best. This is PLA. These are products made from PLA. They look the same, and they can be recycled, but as I say, it's very energy intensive to make it compostable. So I'm going to show you 7 ideas excite you about packaging. These are some of the 7 commercial solutions that we now have in production and that we plan to make in our Saudi facilities. The first one is the paper cup. The paper cup is actually a nightmare, and you are a nation of coffee drinkers. The problem with the paper cup is it has a plastic lining. So you can't put it in the paper bin because it has plastic. You can't put it in the plastic bin because it has paper. If you put it in the ground, within a month, the paper has degraded, but the plastic is there for 20, 30, even 100 years. So what do you do about that? What we've been able to do at Hotpack is develop a number of advanced coatings. The first one, which is in current production, is called a water-based dispersion coating. It has tiny, tiny particles. It still is a plastic. It still has acrylates or styrene in it. But the beauty is that it biodegrades, composts straight away, and the cup can go straight into the paper bin. It can be recycled back round. It doesn't interfere with recycling, and we can make a cup again out of it. We've taken the same cup, we've recycled it 7 times and made the cup again. The new technology that we're working on is mineral coating. Mineral coating is zero plastic at all, from clay, calcium carbonate, silicon dioxide, and we're even looking at seaweed. At the moment, there's a small price increase. The water-based may be, say, 20, 30% more expensive. Mineral coated, perhaps 50%. Seaweed is probably 3 to 4 times the cost. So the first 2 are perhaps commercially deliverable at the moment. These are our advanced lines. We've offered incentivized pricing now to push our customers from the plastic-coated cup to these new aqueous coatings. The next is rPET. This is going to be very, very important for this country. Our machines that we're buying, including for here, can take up to 100% recycled plastic, PET. The reason that PET is collected and recycled is because mainly it's used for bottles. And so on the sorting lines, the sorters can see the bottle, they know it's PET, and so most of the bales of recycled plastic from human waste are PET. And these lines from Austria, from Germany, they can take up to 100% recycled content. But we can't get it. We can't get PCR in this country. I was speaking a week ago, and I think there's 2 or 3 recycling companies. So the key thing we need to work with the government here is to put the infrastructure in place to collect it, to educate people, to sort it, to clean it, and bring it back to our factories. Because we're ready, we can take it. This is at the bottom right, you can see in the middle is a virgin PET cup, on the left is a 30% PET, and then 100% is on the right. It does tend to go a little bit darker. So that's human waste that's been collected, sorted, and made back into the same product. We need to watch, because if we legislate before the infrastructure's in place, then we end up with the R means recycled. You can see the dark blue line creates a large gap. For example, if the SABIC price on PET for virgin was $1,000, we've seen as high as $1,500. So there's a huge differential between the price of recycled content. So we need to, if we have the infrastructure, it should be the same price. This is a very, very famous yogurt company from this country, the largest. I won't say who they are. So they brought us, this is called HPET. This is a lovely technique. So they brought their PET yogurt pot to us, and we, R&D team, at 7.3 grams of plastic in that. What we were able to do was to put tiny bubbles into it, like expanded polystyrene, but in PET. We reduced the weight by 1/3. So you imagine for this giant company, 1/3 less polymer is a huge saving for the country. Fully recyclable, it's still PET, it goes back in the PET stream, and we can make it back into the same cup. So this kind of R&D, we plan to do this again here in, our PET mainly comes from SABIC, but we can reduce that by 1/3. Again, meat trays, you can see 32 grams of meat tray, again, by putting the bubbles into it. And the advantage of the bubbles is it makes it stronger. The honeycomb effect of the bubbles makes the structure rigid, which is fantastic. 1/3 saving again. Okay, another thing is, as I've said, the secret we need is to recycle everything. But just in case it gets in the rivers, just in case it gets in the landfill, which is not what we want, we are looking at putting biodegradable additives into the polymers. And this might be done at source, maybe by a SABIC it can be put in. The advantage is that it will degrade, instead of in 20 years, it will biodegrade within 6 months. And it is not producing microplastics or nanoplastics, which is what happens with oxidegraders. That's why it says non-oxy. An oxydegrader just breaks it down into smaller polymer chains, and you end up with the microplastics, nanoplastics. This allows the bacteria to grab on the outside, and they actually eat the plastic and produce the carbon dioxide, methanes, which are unfortunately greenhouse gases, but it's better than perhaps 20 years in the ground. So that's something we're looking at doing as well, as a safety net. These are some examples. Here you can see the standard polypropylene versus the bio one. They're just the same. So the next one, of course, is the recycling of polyethylene. Here we can take all of the waste bags and we produce the granules at the bottom in the machine above, and we can produce products again fully with PE. We're now producing, again, I don't know if it's in this country yet, 100% recycled content. So number one, it's 100% recycled. Number two, it's multi-use. Number three, you take it back to us and we'll chop it down again and make a new bag out of it when it's damaged. So it ticks all the boxes. Very important to have this in this country. Spinneys as well in the UAE have taken it from us. One of the problems is having a window. You all want to see your sandwich inside the box. So even if you have a paper or cardboard. So we've developed a cellulose plastic now that means that can go straight into the paper stream. It's fully recyclable as paper. It's made from cellulose. It's very important not to have multi-substrate polymer packaging. It's virtually impossible to cycle. When you have aluminium layers and plastic and different types of plastic, it means it can't be recycled, other than into perhaps furniture or a pallet. So we're now persuading all of our customers, where possible, to use a single polymer. It's called monomaterial, and it means it can be recycled as polypropylene, as polyethylene. Lots of new exciting polymers coming out now, from enzymes, from genetic engineering. These is PLA, PBATs, PBSs, all seem to begin with a P. And we've been able to make successfully bags out of these and other products. The problem at the moment is it can be 200 to 300% the cost, which the market won't stand at the moment. But as the facilities come online, they become more mainstream, we expect to see more. So we have a big R&D department looking at all of these polymers. You can even make packaging out of lobster and prawn shells. It's called chitin at the bottom down here. One of the R's, I remember I said it was up to 11, it's actually 13 now. This is a buzzword at the moment called rotable. Rotable means that you make a reusable product, like you see on Emirates Airlines here, and you take it back. Rather than throwing it in the rubbish bag when the hostesses collect it, they put it back in the food trolley now. It goes back on the aircraft to recycling centres where they wash it, and they use it again. And it has a date stamp on it. Emirates were hoping to get 13 months out of it, but because they have to wash it sometimes twice a day at 85 degrees, they're currently getting only 3 months out of the product. It's called rotable because once it deteriorates, it's sent back to the factory like hot pack. We melt it down again and make the same product out of it again. This is a plastic called ABS, but there are disadvantages. Again, these are rotable products, so it means rotate and then remanufacture it back into the same product. We need to watch, because when you're using these rotable products, you have to make sure that you get a high number of uses out of them compared to perhaps paper or plastic. And here's an interesting one. So, for the first time ever, I was in the Palm in Dubai, and I ordered some food. I was late. I missed the restaurant. So I ordered from Talabat, and the driver brought this to me. And I thought, wow, I've never seen it. I talk about it all the time, but I've never seen it. And I said to so we'd ordered the chips, the salad, and it all came in different heavy-duty, multi-use compartments. And I thought, that's very interesting. So I said to the driver, how is it? Is it good? And he said, Mr. Mike, it's terrible. He said, before in the back of my motorbike, in a paper bag, I could fit 12 meals, okay? But now with these, it's so heavy, so big, I can fit 3. So now I'm having to do 4 times as many journeys to serve the same amount of food. And it's having to go back and be washed and detergents and so forth. So not everything is ideal. We need to do evidence-based. We need to, before we jump on things like this, we need to do research and look, is it really the best solution? As I've said, we need to think about, in this country, as we build the infrastructure, how are we going to recycle? The reason that PET, as you can see here at the bottom left, is recycled is because it's easy to see the bottles, and 99% of those are PET. Nobody bothers to look at the little symbol on the bottom of the product. So one of the ways that we're thinking about recycling is something called a digital watermark. You either print it within the logo. You can't see it with your eye, but there's a recycling coding put in the print that the recycling centres, the automated centres can see, and you can get up to 99% efficiency. Or you can put it in the polymer, but the disadvantage is it's very expensive. So for paper cups, for other things, digital watermarks are a perfect solution, but not practical. So one of my ideas is perhaps if you really want to recycle the polymers, not just PET, perhaps we need to think about sacrificing something. And that something is perhaps to colour code the plastics. So we say, okay, these are the sort of 4, 5 main polymer groups. Let's colour code them. Let's have 2 colours for each plastic. We'll have PET as blue and black, PP green and yellow. And so when we see the colours with the human eye, we know where to put them. You can see them all graded here. This is a practical example. Here you can see the different polymer types. You can identify PP bottles, PET, and it allows us to sort them properly so we can bring them back to hot pack to be reused. The human eye can detect 0.2% tint. So you don't have to put much in. It's virtually free. The cost of tinting, putting additives in the polymers is free. And the automatic sorters, near infrared on the top right there, again, can sort with 99% efficiency. So these kind of ideas are some things we're looking at. The nice thing is once you start to color code the plastics, is you can start to sort at home. Instead of just having a glass, paper, metal bin, perhaps you could have a different bin for the polymer types, and you just put them in based upon color. And if you want to brand, you just print or put a paper label on it. So this is my dream, is to have you all sort, and the whole country, to be taught to sort the plastics because they are valuable and we can reuse them. I never thought I would see it. And this company, Degrade in Dubai, they actually have it in their reception. And their staff are trained to put the different polymers in the different plastics. And that means we can use all of it again. Thank you very much. Thank you. Any questions? Hi.
You mentioned in your presentation that you have helped a local milk-based company to reduce the weight of a yogurt cup from 7 grams to 5 grams by inducing some technology that created bubbles within the honeycomb. So how it was achieved? By mixing, say, polystyrene with polyethylene?
No, it's pure PET. And the bubbles are nitrogen. It's similar to what's used in expanded polystyrene. So if you take polystyrene, you put bubbles in it for your burger container. That's very hard to recycle. So we inject nitrogen into the PET. It's pure PET, 100% PET. And then one of the problems you have with it, there is a catch, but we've solved that, is when you come to recycle it, the recycling lines, they allow the plastics to come out at different weights. And if you put too many bubbles in it, the PET comes out in the polypropylene section. So what we've been able to do is get the right balance. We can go up to 50% weight reduction, but at 33%, the PET is coming out in the PET. So we inject the bubbles into it in the extrusion stage.
But it will create a challenge for the processors to handle the nitrogen or pentane if you put pentane as
No, it's not. The lines it's quite a well-established technology. In the market, it's called foam PET, and it's been around for a long time. No, you have to have the machines to do it. You have to invest. I mean, we can buy a cheap Chinese machine at Hotpack for $500,000, and it'll last 5 years. If you want to do 100% recycled content, you want to do HPET with the bubbles in it, you need to spend €3 million each machine. So you have to invest in machines that can do this.
Thank you so much.
Pleasure.
Okay, thanks, Mike, for that. Interesting for me. For me, just I need to focus more on the recycling or for the PET with nitrogen. Now, let's go to the steps that, okay, these yogurt packs are used, and then they are returning back to be recycled. Is this nitrogen will affect the material when I need to sort it, or how it will work?
Not at all. In the Starlinger lines, so the best sorting lines in the world for PET are usually Starlinger SML lines, and they can take it just in the normal stream. And because of and chemical recycling again takes it back to the base polymer. But for the mechanical machines, it's no problem. The Starlingers they've been designed to cope with HPET. So it's not an issue. It just goes in the normal PET stream. The secret was to get the 33%. If we were at 50%, it was a problem. It was separating in the wrong, the plastic was coming out in the wrong type of plastic. Okay. I think one of the things we need to do, and we're already talking to SIDF, is to make sure that we put the infrastructure in this country. We've got to, what I like when I sit on your national steering committee is that you are thinking and you are doing it slowly and carefully, because it's so easy. I see in other countries around the world to just jump on a bandwagon and follow everybody else, biodegradables, compostables, legislation. We need to do it slowly, and we need to build the infrastructure in place. But it has to be evidence-based. We're actually bringing in some of the best experts in the world, and I hope you'll attend to a forum very soon, an expert forum, and they are going to say, look, forget what you think about biodegradables, compostables, come and listen to what the evidence is showing. And let's make policies for this country based upon the evidence. Yeah, very important. Yeah. Thank you very much. Thank you.
Thank you, Dr. Mike, for sharing valuable insights about sustainable packaging. Now, before concluding, I would like to request Mr. Ahmed Al-Baghawi, please come on the stage, Vice President of Market Studies, and have momentum to award the participant. Dr. Mike, please come on the stage.
Thank you very much, Pastor. Look forward to a long future in your country.
We thank all guests for joining today, and despite your busy schedule, we look forward to see you soon, inshallah.